All right, so y equals x is just the line, y equals x, so it's this line here. Right, this line here going up. And now this one's the parabola going, U-shaped. So again, if you're not sure, just plug in some values. So if x equals 0, y equals 2, so it's right here. If x equals 1, 2 minus 1 is 1, so they cross here. And if x equals negative 1, you still look at the same thing. And if x equals, let's say, 2, you get negative 2. So down here. So it does roughly that. So this is our region right here. Right there. Okay. All right, so now that we have a region, and now you can notice why we do, top minus bottom in this case. So if we use our rectangle, right, there's our top minus bottom portion there. So we know it's going to be the area is equal to the integral of the top, which is going to be this portion. So 2 minus x squared minus the bottom, which is just an x dx. Now here's the problem. Where is our bounds of integration, right? That's what we got to figure out. So in that case, we're going to have to solve for x. Or, if you just look at the graph you did correctly, we know that they cross right here. Right? Those are our crossing points. And we just figure what the x values are. Well, it crosses here at negative 2, right? That's the x value, and it crosses here at 1. So we really actually didn't have to solve for it, right? Again, as long as you look at the graph, and it wasn't too bad, right? But again, if you didn't have to do it, you just set them equal to other, so x equals x minus 2, and just solve for x there, and you would get negative 2 and 1 as well, right? Just use factoring methods to do that. Okay. Right, so now we just do this process. So integral of this is just simply power rule for each case, right? So this is going to be 2x minus x to the third over 3 minus x squared over 2, evaluated at negative 2 and 1. Okay. All right, so this is where we get a little bit of hectic, right? Because there's a lot of fractions everywhere. So if we plug in 1, we're just going to get, let's see, just go to 1, so we get 2 minus 1/3 minus 1/2. And if we plug in negative 2, we get negative 4, positive 8 over 3, and negative 4. 4 over 2 is 2. Okay, let's see what we get here, right, when it comes to it. All right, let's see. Okay. Well, this isn't too bad. It's going to be negative 6 there, so that's not too bad there to get that value. No, I'm just going to see it on a piece of paper. Do this. Just like everybody else, I don't really like adding the fractions together, but, sometimes we got to do this itself, right? So common number is going to be 6, so we're going to have each one by 6. So it's going to be 6 times 2 is 12. Multiply this by 2. Multiply this by 3. Okay, that's that portion. And then on this side, this is going to be negative 6 plus 8/3. So if we do 3, it's going to be 18 over 3. Just adding these two together here. So 12 minus 2 is 10, minus 3 is 7. So 7, 6 minus this value. This is 18, so this is going to be negative 10 over 3. So plus 10 over 3. Same process, so multiplying this by 2 gives you 26. So this is going to be 27 over 6. And dividing each one by 3 gives us 9/2. Oh boy, right? Lots of fraction stuff. So that's just an area, unfortunately, right? So this is when it's a little bit more difficult because area is now bounded between curves themselves. So now that we have this, now we can finally find our x and y coordinate pair. So integral of 1 over a, so 1 over 2, so it's just going to be 2 over 9. Integral from -2 to 1, x times the difference. So essentially it's going to be the same thing. Okay. Distribute the x. And again, I'll just integrate individually. So power rule again for each one, right? So this is going to be x squared minus x to the 4th over 4 minus x to the 3rd over 3. Evaluate at -2 and 1 of 2/9. Okay. All right, same process, right? So plug in 1, plug in -2. So we plug in 1, we're going to get 1 minus 1/4 minus 1/3. This whole thing is being multiplied by 2/9 minus a bigger one. Here plug in -2, so -2 squared is 4 minus -4 to the 4th was 16. 2 times 2 is 4, 8, 16. 16 divided by 4 is going to be 4. And this is going to be 8, positive 8 over 3. There. Oh, that's kind of nice. These cancel. That's too bad there. That's good. Again, right, if you guys can do this fraction, just again, for the sake of time, what you end up getting is, believe it or not, actually just -1/2 after all the calculations. Okay. And then we do the same thing for the y value. So y hat is going to equal to this stuff here. So again, 2 over 9. And we have, okay. So it's going to be integral. Again, I'll just take this 1/2 out. So times 1/2 integral from -2 to 1. And now this is the toughie. Squared minus x squared dx. Okay, so here we're going to have to FOIL, right? So again, just quickly do some FOILing method. So again, here we'll have integral. Notice those cancel, so we just get 1/9 integral from -2 to 1. So if I just FOIL this out, this should give us approximately this if I did this correctly. And then subtracting the minus 2x, it should give us that dx. Okay. And then we just use power rule, right? So there we go. All right, and then we plug in, so we can get, we'll put 1/9 at the very end. So we'll have 4 plus 1/5 minus 1 minus, and when we plug in -2, so -8 minus 2 to the 5th power, I think it's 32. Yeah, 32 over 5 minus, and this can be plus 8. So lots and lots of work here, right, when it comes to it. And again, notice some cancel, so cancel, cancel. This ends up being 3, right? So 3 and 1/5 essentially are happening. And this is -32 over 5 here, right? So let's see if we can slowly simplify this out. So this is going to be 15/16 over 5. Minus minus makes positive. Right. So this ends up being 1/9 times the sum. So this is going to be 48, I believe. So this is 48 over 40. And that is our y component right there. So our point, or center of mass, or centroid, is the point negative 1/2 from our previous one, right? That was x itself, negative 1/2, comma, 48/45. That is our center point. So if you want to kind of guess over here, negative 1/2, so roughly here, and up barely over 1. So actually kind of the corner right there is going to be our centroid. Pretty cool stuff. You can actually figure that kind of stuff out. Well, to me, it's pretty cool, right, when it comes to it. So that is our applications of physics and engineering when it comes to it.